In our last lecture, we'll discuss multidimensional arrays, and we'll also introduce the vector class.
We've already talked about dealing with one-dimensional arrays and two-dimensional arrays, but what about arrays with more than 2 dimensions? Well, I have some good news for you. Well, it might actually be bad news depending on how you interpret it, but in Java, there is no limit to the number of dimensions we can have in arrays. We can have 3, 4, 5, 20 dimensions. Now, with that said, there is still a finite amount of memory. So, like if you tried to declare a 1 million dimensional array, and let's say each dimension has 1 million elements, I don't think your computer is going to have enough memory to allocate that space. But the whole point is that we can have more than 2 dimensions for our arrays. So in order to make this work, well, the first step is we need to declare a multidimensional array. Now the way we do this is just that we include a pair of square braces or square brackets for each dimension. So for example, if I created an array of like 3 different dimensions, I would need 3 square braces. If I create a 5-dimensional array, I would need 5 square braces. So here's some code that shows at least the format of how we would do it. So we'd have our stored data type, and we would still have however many dimensions we need. So we just need however many square brackets. So if I need a 10-dimensional array, I just have 10 square brackets. I have my name of my array equals new data type. And then once again, I would include a pair of square braces for each dimension. And then in there, I would put in the size of each dimension. Now for accessing a particular element in this array, it's no different than 1 or 2 dimensions. It's just that we need to include these square braces for each dimension. So like in this example, I have my array name, index 1, index 2, 3, 4, 5, up to n, however many dimensions. Now, just like with two-dimensional arrays, each index in here has to be a non-negative integer, and it has to be less than its respective dimension. So like for example, the index for the first dimension, it's got to be less than the size of that dimension. The index for the second dimension has got to be less than the size of the next dimension, and so forth. Let's take a look at an example of a 3-dimensional array. So I have double with 3 square brackets. My array equals new double, and I have 10, 5, and 7. So this is a 3-dimensional array. The first dimension is of size 10, which means the valid indices would be between 0 and 9. The second dimension would be of size 5, and the valid range would be from 0 to 4 for the indices. And the third dimension would be of size 7, and the possible range of indices would be from 0 to 6. Now, so we have all these dimensions, and we have so many elements with each dimension. If we want to get the total number of elements, it's just simply going to be the product of all the dimensions. So for example, the total number of elements in my array is going to be 10 times 5 times 7, which is going to be 350. And just like one-dimensional arrays and two-dimensional arrays, every single element in a multi-dimensional array can be treated as an individual variable. So for example, I can do my array 2, 3, and 4 and assign the value 5.5 to that one element. So in this case, a single element is going to consist of 3 different dimensions in order to get that one element. Now, if I want to process each element in a multi-dimensional array, we're going to need a for loop for each dimension. That's the key thing here. So with one-dimensional arrays, to process it, I needed one for loop. To process two-dimensional arrays, I needed 2 for loops. So if I had a 3-dimensional array, I'm going to need 3 for loops. So if I have an n-dimensional array, I'm going to need n different for loops in order to process each element. So here's an example where we initialize all the elements of my array to 10. So notice we have 3 different for loops here. So I have I that goes from 0 to myArray.length. And then inside there, I have another for loop where j goes from 0 to myArray.i.length. And remember, in this case, when we're in this inner for loop, we're dealing technically with a 2-dimensional array now. So now I have to go into one more for loop. So k is going from 0 to myArray.ij.length, and that's giving me the number of elements of that array. And then I can do myArray.ijk and assign the value 10 to it.